Hey everyone, in today's video I'm going to cover network related configurations. So that will usually include things like changing your IP address, configuring DNS servers, adding in routes, checking your ARP tables, and things like that. Alright, so to get started, let's figure out how to actually check what our IP address is and to monitor our interfaces. So the first command you need to know is IP add. This is going to list the different interfaces that we have on our system, as well as their IP address, their IPv6 address, their MAC address, and things like that. All right, so the first interface that we see, we actually have three different interfaces on this system. The first one is this LO. So you'll see this loopback interface. That's what LO stands for, is loopback. And this is going to be seen on any system, and it's always going to say, it has the IP address of 127.0.0.1. Okay, so this loopback interface just represents itself. So if you ping 127.0.0.1, it's basically saying ping yourself. So that address, the 127.0.0.1, is always going to refer back to the system itself. This is just something that all systems will have by default, so feel free to just ignore it for the most part. After that, we have two other interfaces. So these are the two physical interfaces that actually exist on this Ubuntu server. And the first entry here is the name. So we have ENS33, so that's the name of this first interface. Then we have the MTU. You can see that the state is up. Then beneath that, we have the MAC address of the interface. Okay. Then we have the broadcast address, and this should always be all Fs. That's just how Ethernet works. This is all the bits set to 1, which means that this is going to send your packet or broadcast packet to everyone in your network, everyone in that subnet specifically. Then beneath that, we have our IPv4 address. So this is our address 192.168.0.6/24. Then the broadcast address is 192.168.0.255. Let's see what else. Then we have all of our IPv6 addresses. There's going to be our actual physical IP address. We're going to have a link local IPv6 address, but just skip that for now. Then if we take a look at our second interface, ENS38, it's going to show similar information. MTU 1500, the state is up. This is our MAC address for this second interface. This is our IP address for this interface, the broadcast address for that subnet. It's also got some IPv6 configuration as well. All right, so that's how we verify the interface state. So if you do IP add, you'll get all the information you want. If you've worked on previous Linux systems, you'll probably know the command ifconfig. So that's not enabled by default on newer Ubuntu versions, but people still use it a lot. So if you want to check your IP address or your interface configurations, feel free to use ifconfig if you're running on a release that still supports it. And you can always still install that by using the sudo apt install nettools command. All right. So right now, I do want to tell you that this address 192.168.0.6 was actually not statically defined, and it was learned using DHCP. So by default, when actually this applies to all machines, not just Ubuntu, but your Windows PC, your smartphones as well, they're all configured to receive an IP address using DHCP. And if you don't know what DHCP is DHCP is the protocol that allows us to automatically receive an IP address. Because every device on the network needs to have an IP address to communicate with other devices on the network. When you plug in your computer into the Ethernet jack, or when you connect into your Wi-Fi, have you ever had to go into your device and actually configure a IP address to talk to the network? No, you just connect it and you're automatically able to browse the web. And that's because of the DHCP protocol. And basically, there's a central device called the DHCP server that has a pool of available IP addresses, and every time a DHCP client, which would be any user connected to the network that's configured to use DHCP, anytime they connect to the network, they'll request to receive an IP address from that server. The server will look at its pool of available IP address, and it'll provide you with an IP address. And this is all seamless and done in the background, and it's all fairly quick, so that once you connect to the network, you can immediately start talking to other devices on the network. And DHCP and the server itself will handle dealing with like duplicate IP addresses and things like that to prevent any issues. But just keep in mind that this is the default configuration, but usually when you're working with servers and things like that, you're probably going to want to statically define an IP address. And the reason for that is when you do DHCP, you're not necessarily guaranteed to receive the same IP address every time. So if I shut this machine down and bring it back up, I may not get the 192.168.0.6 address. They might give me the .07 address. And this could potentially break other applications that need to know that my IP address is a fixed value like .0.6. Because if they're pointing to .0.6 and then all of a sudden I change my IP address to 0.7, well, then I've just broken communication. So generally you want to statically define your devices so that all other devices trying to communicate with it will know that that's your IP address, and it'll stay that way, moving forward. All right. So the way that the IP address is set on devices and the way to change it is by modifying a specific file. So go to cd/etc/netplan and then do ls. And let me just remove this real quick. So just to not confuse you guys. So if you look at this folder, we'll have one file. Now, based on what machine you're using, this file may be called something different. Okay, but basically just remember that there should be a file. It may be called this, it may be not called that, but it doesn't matter. There should just be the one, and you'll be modifying that to change the IP addresses of interfaces. So before we look at this file, let's go ahead and remember our interfaces. Okay, so remember these names: ENS33, ENS38. So I'm going to show you an example on how to change the IP address of ENS38. So let's go into sudo vi. Let's open up that file. And you can see here that there's basically no configuration. So it's just using whatever the Ubuntu defaults are. Now, if we want to override that, go ahead and just create a new line. And this is very important. This is a YAML file. So with YAML files, the actual spacing matter. So don't just put it, any line willy-nilly wherever it needs to. You need to make sure that the spacings are exactly matching the correct number of spaces. So if you look here, there's two different spaces, and then the word starts. So we want to go 2 spaces and make sure they're not tabs. We want spaces, okay? And then we're going to type in Ethernets, : hit enter, then hit 2 spaces to get to Ethernets, then hit 2 more, and then put the name of the interface that you want to modify. So in this case, it's going to be ENS38 because I want to change the second interface. Your interfaces will probably be called something different, so just grab the correct name and then feel free to follow along with this tutorial. All right, then put : keep hitting spaces, do not hit tabs, then once you get to here, hit 2 more, and then put DHCP4. So this is the DHCP configuration for IPv4. Now, by default, it's essentially saying yes. So if you don't have this configuration in place, it's the same as just writing this, which means that we want to automatically get an IP address, automatically get a default gateway, automatically get a DNS server from that DHCP server in our network. Okay, so what we want to do is now change the configuration so we don't use DHCP and we use static IP address. So hit delete on that and just type in no. So this means we're going to statically define our IP address now. All right. After we do that, then go to just beneath DHCP, type in addresses, and then put the IP address. So let's say we want 172.16.1.1, the prefix length of that subnet, and then close that bracket. So that's where we define the IP address, the new IP address for the interface. Then we want to define the default gateway. So this is going to be the device we send all traffic to when we want to route out to the internet or to some other subnet that we are not directly connected to. in your home network, if you're not familiar with networking, these are all probably new terminologies. But in your home network, your default gateway is usually going to be your little Linksys router or your Verizon or AT&T router. That's usually your default gateway, and then that device will know how to get out to the internet. So we do gateway 4, and then we put the IP address. So let's say it's 172.16.1.254. This device doesn't actually exist in my network, but I just want to show you how to actually configure that. Then we configure name servers. So the name servers are DNS servers, and if you don't know what DNS servers are, they just resolve host names. So instead of reaching out to devices based on their IP address, we can actually reach out to them based off of a specific name. And then this DNS server will provide the mapping to an IP address so that we can actually connect to it. And if you've never seen DNS, I can assure you you've actually interacted with it many times. When you connect to, let's say, YouTube, right? When you go to youtube.com, you have to remember that a web server is just a server like any other server that just serves a user an HTML file. So when you go to youtube.com, you're physically connecting to a server, and that server is just serving you HTML files, okay? But if you think about it, you have to remember that all devices need to have an IP address to communicate. Well, what is youtube.com? Like, what is that? That's just a domain name. So that's just an easy name for humans to be able to represent that server that Google owns. But what we need to do is now figure out what IP address that server actually has, and we use DNS for that. So there's a server somewhere in the internet that will basically respond to queries. So we'll send a query out to that server saying, for youtube.com, what IP address is that server at? And then he'll respond back with, oh, it's at 1.1.1.1. And then we can send our HTTP, get towards that IP address. So that's what the DNS servers are for. If you're in an enterprise, you'll probably have some internal DNS servers. You can also point to Google's DNS servers, which is what I'm going to do here. So let's just hit that, and then 2 more spaces, and then we do addresses. You want to make sure everything's spelled correctly. And then here you can list the addresses. So if we do 8.8.8, and then we can do 8.8.8.4.4. So I believe these are Google's public DNS servers. And you can put as many DNS servers as you want. You can also add in another extra line and put in some more. So I can put, whatever, 1.1.1, right? You can group them however you want, or you can stick them all in one line. It's just a matter of preference. But I'm just going to keep these 2 DNS servers. And you don't technically have to configure these if you don't want to. You don't need to have a DNS server technically. Then after we configure the name servers, that's actually all the configuration we need. So this, just to recap, is going to disable DHCP so that we statically assign an IP address. This is going to be our new IP address. This is our subnet or a subnet mask. This is our default gateway. And this doesn't actually need to be set either. We don't technically need to have a default gateway. And when you have multiple interfaces, generally you only want one of them to be configured to have a default gateway, because there's really one interface you want to go to reach out to the rest of the network. And if you use 2 different interfaces with default gateways, that means it's going to load balance between those 2 interfaces, which might not be what you want. So just keep that in mind. Generally we're going to use it. We're going to have a default gateway on only one. In this example, technically ENS33 already has a default gateway, so I'm now adding another one to this interface, which is less than ideal, but I just want to show you guys how to do it. Okay, then go ahead and save the changes you made. And if you look at the IP address now, you can see nothing's changed. And that's because we have to run the command sudo netplan apply. So this will actually apply the configuration changes, and it'll restart your network manager service as well. Okay, so we've applied that configuration. If we do IP add now, you can see here that the new configurations took place. So we have 172.16.1.1. That's our broadcast address for that subnet. So our configurations did work. So this is using a static IP. This one is still using DHCP. We can change that if we want, but I want to go on to the next topic at this point. So the next thing I want to talk about is routes. Okay. So just like a router or a switch, technically your server also has a routing table, and to see that routing table, you just do IP route. And let's go line by line and explain what these routes do. Okay. So I told you that when we have a default gateway configured for an interface, it creates a default route. And this is what the default route is. So it's basically saying 0.0.0.0/0. So to get to any subnet that I don't know how to get to, go to this address on this interface. So this address is found on this interface, and you can see that's part of the 192.168.0.1 subnet, which is this interface. And you can see that this interface also happens to use DHCP, and there's a metric associated with that route. And then we also have a default route for this interface because we configured the default gateway in the netplan configuration. Then let's look at, we'll skip this line for now. But here we have the 172.16.1.0, which is the subnet this interface exists on. So this is the equivalent of like a connected interface. So Linux is smart enough to know that, hey, I have an interface that's physically connected to this subnet. So if I want to go there, I'm just going to use this route that I installed for you automatically. And the same thing applies for ENS33. We're on the 192.168.0.0/24 subnet. So if we want to send a packet to another host on that same subnet, then we would use this specific route. With this routing table, we can add in as many specific routes as we want to kind of tweak the direction in which packets go, and what interfaces they leave based on what subnet. So if I wanted to, let's say I have a subnet or a VLAN for, I don't know, like voice traffic or something, or a subnet that hosts like mission critical information or mission critical applications. Let's say I want that to always take ENS33, then I can say, I can create a new route that says, for those subnets, take ENS33. And then let's say if I just want to, for unimportant traffic, I can force that traffic to get sent out ENS38 by configuring a route that points out ENS38. So there's a lot of flexibility with these routes. Feel free to tweak them as much as you want. You can get pretty flexible with them, and if you have more interfaces, then you can always change up your routing so that each interface handles different subnets and things like that. Okay, to configure routes, we need to go back to our the netplan file that we tweaked to change the IP address. So go to that file, open it up with your favorite text editor again. Then under each respective interface, we then configure our specific routes. So if we want to configure a route for ENS38, just go here and then type in routes. And then this is the format that you do. So then you do a dash, and then we put 2, then the name of the subnet or the subnet itself. So let's say I want to put in a route for 1.1.1.0/24. So to get to this subnet, I need to go to let's say 172.16.1.12. Okay, so to get to this address, send the packet to this next hop. That's what that route is saying. And we can put in as many routes as we want. So let's say we want to go to, I don't know, 10. Actually, let's do 160.0.10. Actually, let's just do 0.0. Make this a /16. Via. And then let's say we'll send this to 172.16.1.4. And that's all the configuration we need to do. So we should now have 2 new routes. And just with any other configuration to the netplan file, we need to apply the changes. And then if we do IP route, you can see the two new routes that we just put in. So there's the 160.0.0.0/16, and then there's the 172.16.1.0/24. And we can, and both of those routes also point out the ENS38 interface, but we can configure a route to point out ENS33 with the same exact configuration. We just have to, instead of putting ENS38 here, we would do ENS33 and then configure a routes section and then put in our respective routes. So that's how we change the routing table in Ubuntu. The next thing I want to show you, it doesn't involve any configuration, but it's just something that you should know how to do, is how to check the ARP table. And if you don't know what ARP is basically the IP to MAC binding of a host. Okay, so basically, when you want to send a packet to a specific IP address, what you're going to do is, if he's locally connected on one of your subnets, you're going to ARP for that host so that you can learn his MAC address, and that'll allow you to populate the Ethernet headers of the packet. Okay, and to see the ARP entry on your device, just do IP nav, and this is going to show you your ARP entries. So right now we just have a couple. So we configured this route that points to 172. I configured the default gateway for the ENS38 interface to be 172.16.1.24, which doesn't actually exist. So it tried to ARP out for that device and it failed because that device doesn't exist. So that's why that says failed. But my physical PC, the Windows PC that I'm on, that's this guy right here, is on the same subnet as this interface, ENS33. So if I try to ping him, let me just get my IP address. Let's see, where is it? 192.168. Nope, that's not it. Where is it? Here we go, 192.168.0.8. If we try to ping 192.168.0.8, we get a reply back, and I'll go over the ping tool in a bit. And now if we check IP nav, you can see that we now have an entry for my PC. So it asked me, 192.168.0.8, what's your MAC address? And I responded back with this MAC address. So that's about it for IP addresses. I do want to cover a few more, I guess if you want to call them network troubleshooting tools. So I just did a ping. So ping just sends these ICMP packets to a host, and it's a great way to test if there's connectivity to another device. So if I just ping a random IP address that I know doesn't actually have a device behind it, like 192.168.0.192, it's going to fail, because that device doesn't exist. It'll tell us destination host unreachable. So it's a great troubleshooting tool to see if there's network reachability between yourself and another device. Another command that I use a lot is the nslookup. So that will basically tell you if we're able to resolve a host name. So if I want to go to youtube.com and it's not working, well, is it an issue with reachability to YouTube, or is it an issue with DNS? If we do nslookup, that should give me, or that should return the IP address of the YouTube server. And if you do that, you can see we do get a response back. So DNS is working fine, and you can see all the IP addresses behind youtube.com. So, the reason YouTube does this is because it's a massive site with a lot of people connecting to it at once. So it's not just one physical server. They have a ton of different servers that you're technically connecting to behind the scenes. But you don't have to know all those IP addresses. You just go to youtube.com, and then, they handle the rest. So it'll get load balanced between all these IP addresses. And the final command I want to show you is tcpdump. So this is how you do packet captures on an Ubuntu server. So tcpdump, and then you can pass in certain parameters. So -i is going to be for what interface. So you can do ENS33. If you want to do all interfaces, you can do any. And then you have a certain, filter or whatever you want to call it. And so these filters allow you to filter down which specific packets you want to capture. So if you want to only capture packets to a host and then a specific IP address, this is going to capture only packets that have a source IP or a destination IP of 1.1.1.